Alright, so today's learning target is that I can write and use a linear equation from a real-world example with and without a table of values. Alright, so earlier on this week we've been learning how to write equations, but it hasn't really been anything other than looking at a graph and saying I can write an equation from this. Like I can write an equation, or given 2 points I can write an equation, or given some information I can write an equation. But the real reason that that's important is because in the real world we can do that anytime we want to. And all we need to write an equation in the real world is a rate of change and some initial value, so some starting point in uh, in a problem, in an issue, in something that I want to model as a linear equation. Okay, so for my first example, it says write a linear equation and answer the following questions using the equation that you wrote. So it says in warmer climates, approximate temperature predictions can be made by counting the number of chirps a cricket makes during a minute. The temperature in Fahrenheit is equivalent to 1/4 the number of cricket chirps in a minute plus 40. Okay, so when the crickets are chirping, saying that 1/4 of them plus 40 gives me the temperature. Okay, and remember 1/4 is a fraction, right? So my two variables, well, it's what are we taking a fourth of? Well, it's the number of cricket chirps. We don't know how many chirps the crickets are making because that's what we're trying to find, right? We need to find the temperature using the number of cricket chirps. So that's going to be my x. Okay, so x is my number of cricket chirps, and my second variable is what actually is the result of this, right? My temperature. Okay, and you want to kind of think of the two variables. X is something that we find that results in something else. Remember, we talked about this a while ago, was independent and dependent variables. The number of cricket chirps isn't dependent on anything. We're just trying to find it. So that's got to be the x. So x must be the independent, or the independent variable. Okay, y has to be the dependent variable. So in this case, the temperature depends on the number of crickets, therefore, or cricket chirps. Therefore, x is the number of cricket chirps and y is the temperature. Alright, so when we're writing an equation, we really need two things, right? A point to start off from and a rate of change, or a slope, right? So somewhere in that problem they've given me a rate of change, and that's my slope. Okay, well, it's definitely not the plus 40, right? Because the 40 doesn't change. You're just adding 40 to whatever you're resulting. But it says the temperature is equivalent to 1/4 of the number of cricket chirps. So my rate of change, what is changing is that 1/4, right? 1/4 the number of cricket chirps, because the number of cricket chirps is changing every so often. That changes the temperature. That means that 1/4 is my rate of change. That's how the temperature changes. Okay, is there a constant or unchanging value? Okay, so in this case, the constant is the plus 40, right? No matter what number of cricket chirps I get, I'm always adding 40 to it, and that's going to be my y-intercept, right? That's the thing that doesn't, if there's zero, if there's no cricket chirps, we're going to assume that it's 40 degrees out. Okay, so an unchanging value would be equivalent to the y-intercept. It's the value that happens when the independent variable is 0, right? Because if I plug in 0 for the number of cricket chirps, then the only answer I'm going to get is 40. So my constant unchanging value is 40. Alright, so now the question is going to answer, how do we use this information to actually write an equation? So because I have a slope and a y-intercept, I'm going to use slope-intercept form. Right? They've given me these two things. So it's easiest to write an equation when you have a form that you have the two things to plug into it.
So for my equation, the temperature is going to be equal to 1/4 the number of cricket chirps plus 40. Okay, so there's my equation. I've got it. X is 1, y is equal to 1/4 x plus 40. Alright. So, the question that I want to answer using this equation, y equals 1/4 x plus 40, is if a person recorded 48 cricket chirps in a minute, what would the temperature be? Well, the number of cricket chirps, remember, was x. So this is telling me that x is equal to 48. So I'm going to use this equation to figure out, to just estimate what my temperature is. So y equals 1/4. I'm going to plug in the x, right? I'm going to assume that it's 48 cricket chirps plus 40. Okay, 1/4 of 48 is 12, so I get y is equal to 12 plus 40, so y is equal to 52 degrees. Okay, so if the crickets are chirping 48 times in a minute, it's about 52 degrees outside. Alright, so my second example here is write an equation from a table. So Joe is saving to buy a new computer monitor. Consider his savings plan below. Write a linear equation based on the data provided, and then answer the following questions. Okay, so if I'm considering this table, so the number of months of savings, 3, 5, 7, 9, and 11. What have they provided me, right? All this is two different variables, right? The number of months that I'm saving and the account balance after that amount of months. So they really provided me a bunch of ordered pairs. Which means that all of these are points on a line. So they provided me with the variables and points on a line. Okay, now again, we have to decide which is my x and which is my y. So when I define my variables, I'm looking at which one is independent and which one is dependent. Well, does the number of months depend on the account balance? No, the account balance depends on the number of months. So my x is going to be the number of months and the y is going to be my balance, because the number of months that I save is resulted from the balance. Okay, now I want to check. Look here, each time I pick a new month, it's been about 2 months, right? I go from 3 to 5, 5 to 7, 7 to 9, 9 to 11. So this is going up at a constant rate. And every time I go up, the account balance is going up by 20. So this is a linear equation. So I'm going to pick two data points. I'm going to go with 380 and 5100. They've given you 5 data points. The only thing that you need to write an equation is 2 of those points, because I need a rate of change and a point on the line. The only thing I don't have at this point is that rate of change. So I'm going to pick the two easiest points for me, and that's going to be 380 and 5100. Okay, so use two data points to write a linear equation. Well, we did this last week, right? I want to find the slope using these 2 points and then plug that in to write an equation. So to find the slope, I need to get, it says use the 2 data points to write a linear equation in slope-intercept form, but the first thing I need to do is find the slope. So that's y2 minus y1 over x2 minus x1. And in this case, we got x1, y1, x2, y2. Remember, the numbers are just telling me which point it is. So either point 1 or point 2. Right, so my slope in this case, my y2 is 100, y1 is 80, x2 is 5, x1 is 3. Okay, so I end up with
100 minus 80, which is 20, and 5 minus 3, which is 2. So equal to 20 divided by 2, which is 10. Alright, so let's go down a little bit. Now that I have that slope, m equals 10, and I've got a point on the line, I'm going to use my x1, y1, right, 3 and 80. I can use that modified slope form that we talked about on our last week. So I've got m equals y minus y1 over x minus x1. I want to plug in what I know. Well, my slope is 10, and remember the denominator in this case is over 1. So I've got 10 over 1. I don't have a y or an x, so those two things are going to stay the same, right? I'm trying to write an equation, so I don't want 2 points, I just want 1. So I'm going to do y minus y1, which is 80, over x minus x1, which is 3, and cross multiply. Okay, so bottoms times the opposite tops. Right, so I get 10, or no, start with the y's, sorry. So y minus 80 is equal to 10 times x minus 3. Now, why didn't I write the times 1? Well, anything times 1 is itself. 1 times y is y, and 1 times negative 80 is negative 80. So I don't really have to write the parentheses with the 1 because it's the same thing. I'm multiplying something by 1. Okay, but I do have to distribute this 10 to get an equation. So I end up with y minus 80 is equal to 10x minus 30. And the equation I want is in slope-intercept form, so all I have to do is solve for y. Right? I gotta get this y by itself. So because it needs to be in slope-intercept form, I'm gonna add 80 to both sides. I've got a like term over here to combine it with. So I get y is equal to 10x, negative 30 plus 80 is 50. So 10x plus 50. Okay, so this is the equation of this graph, or of this table, in slope-intercept form, and it's exactly what I wanted. And over here you should have had the slope calculation. Right? Okay, so now that I've got my equation, I'm going to use it to solve these two questions. How much money will Joe have saved after 2 months? Well, remember, x is the number of months, so they're telling me that in this case, x equals 2. So I'm going to plug that into my equation and figure that out. So pause the video right now and try that yourself. See what you get. Alright, so what you should have gotten was y equals 10, plugging in the x, times 2 plus 50. Okay, well, 10 times 2 is 20, and 20 plus 50 is 70. So he should have $70 after 2 months. Okay, so if Joe's new monitor is going to cost $200, how long will he have to save up using the current plan? Well, that's the cost, right? So the amount of money in his savings account needs to equal $200 before he can buy that monitor. So what they've given me here is y equals 200. So I'm going to do the exact opposite. I'm going to plug in 200 for y. So I get $200 is equal to 10x plus 50. Scroll down just a bit. Okay, and once I have that equation, I need to solve for x, so the number of months that it's going to take him to save up. So I need to get the x by itself. I'm going to subtract 50. Okay, so I get $150 is equal to 10x, and then divide both sides by 10. So x is equal to 15 months. So it will take him, saving $10 a month, it will take him 15 months to save up for that monitor. Alright, so think this over and be ready to talk about it next time we're in class.